Let me now turn to Steve Sherrill and his guest to talk about dead rail or battery power. Again, this is something that I've wondered about for a long time. And frankly, judging by the number of people who are viewing the videos after the shows, as well as the number of people that are participating in the shows, there's a lot of you out there that have the same kind of interest, but don't have much knowledge about what battery power or dead rail or whatever it's called is all about, and frankly, how to get involved in it. So, Steve, I really do appreciate you doing this for us and having the guest and so forth that can give us some guidance and see if we can figure out if this is for us and if it is, how we should get involved. So I'll turn it over to you, sir.
Tonight, we're going to take the basic RC car control or transmitter and do a little modification with it to make it a little more familiar to our model railroad operation. And for this, I have Bob Gelmacher, who is going to present how he modified and created a new transmitter controller that I use on my railroad. He did this for me. He's made a couple of these. So Bob, if you will go ahead, please.
Okay, let's see if we can get this up and running. And can you see my my screen?
Yeah. Yeah.
Okay, we did it right. That's good. Okay, I want to do one other thing and get a pointer option here and get to my laser. So anyway, like Steve said, we talked about using the inexpensive RC car that you can buy on eBay. I think you can buy some on Amazon. I bought a couple of them at like the local Ollie's and see what we can do with it. Steve has already talked about what you can do with the receiver that sits in the car itself. And tonight I'm going to talk about the throttle or the hand controller. And let me start with this. So when you buy one of these little cars, and I would say that the car is probably about maybe 4 or 5 inches long, it comes with two parts. The first part is the car itself, and that's where the motor is and the receiver. And the other part is this pistol-looking type of device that actually controls the car. And that's a better, closer up look at that. And there's a couple of functions on this that are kind of important to us. Number one, on the side, it has an on-off button. And the other thing is when that on-off button is thrown to the on position, the receiver tries to talk to the car itself. And when it does, is that little red light there starts to blink until it syncs up with the car. And then once it does sync up, or once it's paired, depending on what word you want to use, the red light goes solid. So you know, number one, that the power is on, and number two, that you are actually talking to the car that you're trying to control. On the front, there's this big wheel, and that is nothing more than a left-right control. It controls a couple of little motors that are in the wheels, the front wheels, and it either turns them to the left or turns them to the right. And the one that we're really interested in is this speed control right here. And that is a trigger and spring-loaded control. When you pull it back, the car actually goes forward. And when you push it forward, the car actually goes backward. And it returns to a center point, and that's the stop point where the car just stops dead. So what we have to do is we have to take this and try to convert all this into something that is usable for our model railroading. On the back side of this, there are two things. Number one is the antenna. And as it turns out, when we took it apart, the antenna is nothing more than a blank plastic shell, has no function whatsoever, but there is a little antenna in the device. And a very important part is this battery case. And the battery case takes 2 AA batteries. So this whole thing is run, the transmitter part of it is run on about 3 volts. Now, the controller works fine for the cars, and it can control a train, but there are some issues with it. Number one is that spring-loaded trigger that used to control the speed it's really tough to maintain control because you're constantly fighting against the spring itself. And it does require the operator to keep his finger on that control for the entire duration of the use of the machine. And that's pretty tricky. So, and a lot of the other things that we use, we set a dial or something, and then we're finished with it. There is no fascia pocket or holder that I'm aware of where this would look good on any layout. And number 4 is that the form factor for this is not something that we as model railroaders are used to. So what do we do about that? Well, what we did was we said we can convert the functionality of that device from what you see on the left-hand side, which is the trigger itself, to that little box on the right-hand side. And that's exactly what we're going to talk a little bit about tonight. Now, I'll say up front that I'm not going to go into a lot of electrical theory. I'm not going to go into a lot of circuit description. I just want to show you what the mechanical requirements are to get from one to the other. We can talk about the electronics in it at some other time if you want to. This box does the same functionality as that controller. Number 1, it does have a power switch. And when you throw that power switch on, that light does blink again, and it blinks until it syncs up with the receiver in the car, or actually now in the locomotive or the tender. And then we have a direction and speed control, but this time we can actually set that to a predetermined value or a predetermined speed and take our hands off of it, and it'll stay just like any other controller that we're used to. When we open up that box or the controller that comes with the car, there's a couple of components inside that we have to be aware of. And I will use my pointer here. Is number 1, a board that you see on a side view here is the main board. And that main board is where the little transmitter sits. And that is the connections for everything else is in here. That antenna that I talked about before, which is here, is just that blank cone. The actual antenna for this is about a 2-inch piece of wire that is just wired to this main board. And of course, we have to make sure that that stays intact because we need that antenna in order to communicate with the receiver. There's a little potentiometer that sits right behind the trigger here, and the trigger bounces back and forth. And that pot is what talks to the main board and then sends the signal over to the receiver to say, how fast do we want to go? And in what direction do we want to go, forward or backwards? The switch itself to turn this unit on sits behind this board, as does the LED. And the batteries sit in the other side of the handle. This is a molded piece, and you'll see in a few minutes that we really can't use this piece too much. Okay, so if we take away the plastic, the components again are that main board that sits there, and this is the transmitter board. That big dial that we showed before actually activates these 2 little push buttons. And as it turns out, for what we're doing tonight, these push buttons are not necessary. What I want to do is I want to play with this a little bit in weeks to come and to see whether or not these push buttons can actually turn lights on. But they really don't have anything to do with the speed or the direction of a locomotive once we have it in there. This is that auxiliary board where we have the switch and the LED, and that's connected back up here to the main board. And then this is the little pot that actually controls the speed. This is the pot that is regulated by that little spring trigger. And this is the other side of the board. So I've stripped off some of the wires, and this is the trace. Now, one of the issues that I've run into with this is that we have no idea what this chip actually is programmed to do. A lot of chips that we work with, you can find out exactly what program goes into it. You can modify that program if you want to. But this chip, I haven't been able to find out a whole lot about it. So I have to take what they give me and work with it. And it has some other little resistors here, some small stuff. But this is what we call the trace side of the board. This is where the circuit is. And this is the other side, and with a couple of the other components. A critical step at this point is once you get this out of that handheld controller, before you start disconnecting anything, I always say it's a good idea to map all the wiring. And by that, I mean, is to make sure you know where every wire is going to and where every wire is coming from. And if you take a look at that board that we were just showing you, there are different designations on the board and every wire, for instance, on that main board there's a little mark marked as A, and you can see that the black wire from the potentiometer is going into that port and all the way down. The same thing with the aux port. Once we have that information, then we can start disassembling that motherboard or the main board and picking off the components that we need. And after you do all that, this is what we can salvage out of that entire trigger mechanism. The only thing that we're able to reuse is actually the most important thing in there, and that's the main board. So you can see there's the designations that I was talking about, the A and the B and the plus and minus and the D, and we can go back to that chart that I just had, and they correspond to these numbers, and we know where those wires were coming from and going to. Other things that we need in order to complete the project is, number one, we need a case. This particular case is put out by a company called, and I can't read it too well, but anyway, it's about a 2.5 by 4.5 inch case, and it's about 1 inch thick. And as it turns out, it's just the right size for doing what we want to do. It fits in your hand nicely. The nice thing about the case also is that it has a little door here that fits into this area, which gives us access to the batteries, which I'm going to show you in the next slide. The second thing that we need is a battery holder. And these things, I think I got about 8 or 10 of them off of Amazon for next to nothing. And as it turns out, they fit nicely inside of that case. And they're going to hold 2 AA batteries, just enough power to power this mechanism. Some other things that we had to get is, number one, we had to get a potentiometer. And this is going to replace that potentiometer that was actually in the device. When I measured that, it looks like it's about 5,000 ohms. So I picked up a pot about the same value. We have the switch down here. I had that in my toolbox. This is a 5mm red LED. That's going to be our on indication and also tell us whether or not the device has been synced up. I have a little mount here, and this is nothing more than a little plastic grommet that helps to hold that LED in place. It makes the project look a little more professional. And then a resistor. And the reason why we put that resistor in there is because the pot or the potentiometer that's in the device doesn't swing from a 0 point to a max point. There's mechanical blocks in that trigger that keeps it at a point where it goes no longer than about 600 ohms. I think if we let it go below 600 ohms, we probably would burn this whole system out. So in order to ensure that it doesn't, I used a resistor, and I think this is a 570, and put it on one of the leads on the potentiometer in a picture I'll show you in a little bit, to make sure that we maintain that level so that we don't burn out the main board. The next point is, the next slide is, I took the case and I have the cover off, the side off that has that little door that I was showing you about. And it's always a good idea to test fit the components. So here I've got the battery holder in there and it fits just right. And I also put the motherboard in there. What I found on this particular case is there's a couple of little grooves that you see here that are used to put in separate dividers if you want to do it that way. This is one of the posts that the screws is going to hold the back to it. But when I try to wrap the wire from the power around through here, it gets a little bit tight. So what I decided to do, and what I recommend, is that you might want to take a little X-Acto knife and carve off this so that you have a little room to wrap those 2 wires around, and that'll be fine. Also, that I didn't highlight here, there's a divider that's built into the case, and that divider is just a little too snug for the installation of the battery component. So it's very easy to take and just fatigue that piece, bend it back and forth just a little bit until it snaps off, and then the battery case will fit just the way it should. The next step, once you have those fitted, take them out and then drill the holes for the LED, for the switch, and for the potentiometer that are going to stick through. Now, as I say in here, results may vary depending on the particular type of hardware that you buy. The size of those holes is going to vary. So what I always do is I will drill a hole that's a little bit smaller than the actual size that I need, and I will work my way up to that size by taking a reamer and slowly reaming out the hole. You want to have it snug. You don't want to have it too loose, because then you just have a sloppy piece of equipment. The other nice thing about this particular box is across the top here, there's a flat piece of plastic that slides in a groove and also mates up with the other side. So you could very well, and it might be the better way of doing it, is take the hole that you're going to put in for the LED and the hole that you're going to put in for the switch and mount them up here. That leaves a little more room that you can move the potentiometer up a little bit. And I think it's going to make a better job. We didn't do that on the first two, but we're going to do it on the next couple. And then this is what it looks like with everything mounted. And a couple of things that I mentioned is that, number one, before you do and place any parts in permanently, it's a lot easier to add leads to the main board and add leads that are going to be maybe 2 or 3 inches longer than you think you're going to need on the final product. Because once you have that board in place, it's really tough to solder to, especially since the trace is on the other side. So I added all those leads first before I actually glued it in. Once I have that in there, then I use something called E6000 to glue the battery holder and the main board in place. E6000 will not conduct electricity. So even if I put the glue on the trace side and stick it in there, it stays. And E6000, when it dries, it's going to be a very firm glue, but it also is a little bit flexible. So if you had to tear this out for some reason, you probably could. Again, before I soldered or I actually glued the LED, which is here, is I very carefully added wires to the leads on that. You don't want to solder too long on the LEDs because you could burn them out, but at least we have those leads on there and then you can cut them to length as you need them. I mount the switch, the LED and the potentiometer, and then make all the remaining connections. This is one of the reasons why I'm going to go back. I'm not going to physically go back, but I'm going to mention that slide where I said you want to map all of the leads, because that'll give you a really good idea of exactly what gets connected to what. Now, in this particular case, I left some of the wires originally on the main board and I left them on there and I just spliced them in, as you can see here, to some of the other leads that I needed. I was not crazy about this area here. It's a little bit tight, but as long as I made sure that nothing was really touching in there, I felt comfortable that it would work. And then here's that 600 ohm resistor that I mentioned that's on one of the legs of the pot to make sure when we use that pot, we never go below the 600 ohms in firing up this main board. And lastly, on the front side of this thing is, we added the dial, and I picked up a number of dials off of Amazon. And then I think Steve added the lettering on this, and we had a completed project, and we found that it worked very, very well. It gives you a lot of control on the train. In this case, forward is just the opposite direction that it should be, but depending on how you wire the pot would make a difference whether forward is to the left or to the right. Not a critical issue here, but it works well. And we plan to make more of these. Now, there are more expensive solutions. There are more expensive car transmitter cases that you can buy. The components are going to be bigger, but you wind up getting the same result. So I think it was a real good project, and I'm estimating right now that it probably cost about $20 for the components. So when you add that to the cost that Steve has already talked about for the car controller set, it might cost you, $40 or so in order to get a train running on dead rail. But it works very, very well. So with that, I'll entertain any questions that anybody might have.
Bob, I have one question.
Sure.
That potentiometer, does that control both your forward and reverse as well as your speed?
Yes.
So your speed runs from forward to the center?
Yes.
And from reverse to the center.
Right. Now, there's probably ways that we could get around that. We could probably put 2 pots in if we wanted to. But the way the original device was built with that spring-loaded trigger is when you let that trigger go, it springs back to a center point, and that center point is stop. So we and again, I wasn't sure, and I'm still not sure exactly what the programming is in the chip on the transmitter board. So without having that information, I said, I will build around whatever I have to work with. And that's what we had to work with.
Thanks, Bob.
Bob, this is Greg.
Yes. Yeah.
Great presentation.
Thank
And
you.
I just want to let everyone else know, I got to play with this controller and one of Steve's locomotives at the new track scholarship table at Timonium last weekend. And Steve spent a lot of time explaining to me, okay, you got to turn it to the forward to go forward, then you got to move it back and move it to the art. I swear to God, when I picked this up, it was so intuitive and so easy to use. You could get fancier, but I don't really see any need to.
Hmm. I agree. Yeah.
Bob, let me ask you a question. The potentiometer,
Yeah. Hmm.
is that a rheostat?
A rheostat is a potentiometer, but a potentiometer is not a rheostat. Okay, if that makes any sense.
No.
Well, a rheostat is a device that's going to control voltage, and it's built specifically to do that. And it has a potentiometer built into it. This is not made to, and I think of rheostat as being something that's going to control maybe something at 120 volts or something along those lines. This is not made to control anything like that. This is mainly to vary the resistance. And by varying the resistance, you are varying the voltage, but I would not call it a rheostat. No,
Gotcha.
I mean, anybody who works with this kind of stuff is going to call it a potentiometer or a pot, a variable resistor. That's what it amounts to.
Gotcha. Okay. Anybody else have any questions for Bob?
You know,
Bob?
one of the things,
Bob,
Yes.
I have a question. Will you be making this controller, the plans available if we want?
I can, yeah. But I have to make it with the specific car controller set that we are using. So I know I bought maybe a couple of these cars, and Steve has lent me a couple of the car triggers to do. And most of the ones that we worked with so far look like they all are the same. But I can't say that if you pick up any car trigger combination at any store that the components are going to be the same and the wiring is going to be the same. I can only give some general guidelines on that.
Bob, let me ask you this. You say that this could be a basic kind of first solution for somebody that might be interested in dead rail.
Yeah.
The controller,
Hmm.
is that something that could work with a more sophisticated locomotive installation of another kinds of receiver and so forth? In other words, can this controller just be the controller for whatever you would upgrade the locomotive to?
I can't say that that would be true, Jim, because the frequency might be the same, but the functions that the receiver is looking for and the signal that the transmitter is sending out, I just don't know whether they would be compatible. Most of
Right.
these run on 2.4 gigahertz.
Yeah.
And that's what we're going after when we look for the cars and things like that. If I go to a yard sale, if I find a 2.4 gig device, I'll buy it. But I think everyone is going to be different, especially I saw some combinations on, was it Amazon or eBay? But anyway, they were like $59 or $60 combinations. And the people that had them were saying that they were a very generic type of combination. I'm sure that if you dug into them, they would have the same type of components, but I can't guarantee you that those components and the stuff that we just did are going to be 100% compatible. It's going to be a trial and error.
Gotcha. Let me ask you this. If the only thing in the locomotive that you changed was the battery,
Okay.
and left everything else like it was in the locomotive, then would that upgrade still work?
Well, I don't think that we can, that's a multiple point question. I don't think that we can leave the locomotive just the way it is. because if you have a system already that's either DC or DCC, you're getting your power through the rails, which means you're picking it up through the wheels and to the contacts that are on the wheels up to the motor. For a dead rail system like this, I would probably, matter of fact, I will disconnect the motor from the wheels altogether. I don't want to have any connection down to that track. And then wire the motor leads back through the engine itself. And actually, if I had enough room in the engine, I'd put it in the engine. But most of the time on my ON30 stuff, I'm not going to have that room. So I would actually wire it back to a tender and or a secondary tender and have everything back there. So no, I would think that you can't just hook it up to the motor and let it go without modifying the engine a little bit.
Okay, so now I've modified the engine
Right.
and I'm using the battery that came with the car.
Okay.
Can
The battery and the receiver that came with
Yes.
the car.
Yes.
Yes.
If I change that battery in the receiver that came with the car to a larger battery, that's the only change I make, will everything else work?
No, because for instance, the receiver that we were using here, that little main board, they designed that so that it works with a certain voltage. If we were to put more voltage on that board, we'd probably blow it out. For instance, and I think we talked about this last time, is that we're only going to be able to put out probably about 3 to 3.5 volts to the engine motor. So it's going to go relatively slow. Where I know that a lot of motors in our engine, especially my ON30 stuff, would like to see 12 volts to run it at really a faster speed. If we try to put a bigger battery on there, I'm afraid we probably would blow that board out. The components just couldn't handle the actual additional current and voltage that we put on there. So these have to be matched up and rated.
Gotcha.
Wish
So
I had better news there, but that's the facts of life.
So if we're trying to, okay, so I think I understand the limitations of this unit.
Mm-hmm.
So now I want to buy the car kit, I guess, that'll allow me to have the 12-volt battery. What is?
I think what you'd have to do a little bit of research and check the specs on the box of the car kit that you're buying, and they should have on there the size of battery that is needed in the car in order to make the car run. I mean, I've seen ones that are, matter of fact, I've got one right here. Where is it? This battery is a little bit bigger if you can see it. And It is a 7.4, 450 milliamp hour battery. So that's going to give a little more oomph to that receiver, consequently, a little more drive to the motor. But you're talking about probably getting bigger receivers when you do that. And then you got to worry about the size constraint on your engine, whether or not you can put that receiver in there or in a tender.
I got you.
Yeah.
Okay.
Remember now, this is just introduction basic. This is probably the minimum that you can get for dead rail. It's 3.7. The price is the lowest you're going to get. When you want bigger engines, larger scales, you're going to have to step up and go to something like Loco-Fi or some of the other manufacturers that are making this units that will allow you to have more voltage through them, through the boards. So you have to understand that this is very basic stuff here.
Yeah.
Now, one of the reasons why I actually got Bob involved in these this type of controller was I tried everything I could to make that handheld pistol grip work. I got it to work forwards and backwards, but I tried things like taking the spring out, thinking if I pull it back a little bit, would it hold at that point? No, it won't. I tried making the finger holder, modifying that, making that bigger, making it the front, cut it down so it would be easier to fit my personal finger. Didn't work. So that's why we ended up doing this type of system. Now, we'll say this controller will control one of the locomotives that we have. It will also control any of this type of locomotive. So if I have 10 of these, this particular controller, all I have to do is hook up each one of these separately, and I can run it. Now, I hope that's understandable. You know.
So
I
you're-
do-
what you're saying is the box that we see on the screen, that'll run one locomotive.
At a time, I can run any of the locomotives that have this system. Okay,
With this box that I'm seeing on the screen.
this box right here, exactly.
So how do I tell which locomotive I'm going to run with the box I see on the screen?
Well, you have to, you see the little red light, that's going to flash. Okay. Now, when you turn on the receiver in a particular locomotive, the one you selected, that red light will go solid. You know you will have that locomotive.
You lost me. I can't see you. All I can see is the box. Maybe
That's
we
what
ought to,
I'm telling you on the big picture here. When I turn this switch on,
I can't
see
see
the-
the big, I can't see the big pictures, I guess. I see you down in the bottom, little bitty picture.
I'm gonna stop my share. That
Yeah,
way you can see everything. If I can get down there. Come on. And Jim, to answer your question quickly, is that if you have 10 locomotives, the one that you turn on is the one that's going to talk to this box.
right,
and
Okay.
how do I know which one that is?
hold on.
That's the one you turn on.
How
Okay.
do I turn? I didn't know I had to turn the locomotive on. I thought all of them were ready to go.
Well, they're ready
No.
to go, but you got to remember that you have to turn them off because you can't have the battery on all the time. You wouldn't want that to be the case because it's even though it might not be running.
So I got to flip the battery switch on the
got it.
locomotive I want to run, and
You
then
got
I
it.
can run any one of those 10 with this same box.
You got
Correct.
it.
Got it. Okay.
Okay, there we go.
Yeah.
Everybody
So
leave?
No, I don't think so.
you see the flashing light?
Yeah.
Okay. I don't know.
Right there, right,
so I have a
Right.
locomotive right
That's
here.
good. Leave it alone
I'm
right
gonna-
there.
right there.
Hold on. What's going on here? Hold on. I want no failure. This thing is.
It's called the
Huh.
present. It's called the presentation curse.
No.
It ran yesterday.
You know how many trade shows I've been
Impractical.
where we would spend an hour getting everything ready and
Uh-huh.
doors would open and poof, gone.
Have I run my battery down now?
No, not yet.
I must have left it on. Anyway, that's what happens.
Yeah.
Yeah.
Let me say something too about that Loco-Fi system that we talked about last week. Steve let me borrow it, and after I read the instructions, that's a critical part. After I read the instructions, it works like a charm. And I had that hooked up to one of my ON30 moguls, and I was able to run the thing at full speed. Now I did have a 12-volt power supply hooked up to it, but I tested it at lower voltages. And if somebody's looking for a nice, relatively inexpensive dead rail entry point, I was really pleased with it.
Okay.
Well,
Steve, Ken
yeah.
Meyer.
Ken Meyer, hold it, let me introduce you, Ken. This is Ken Meyer. He works closely with Loco-Fi. He has been in RC control for over 40 years, I think he told me, Ken, but it's in airplanes he started out. So he's very experienced. He's going to make a presentation about Loco-Fi on November the 8th. The owner of Loco-Fi will be on with him, and they are going to be showing an install, operation, how to hook it up with the phone. They're going to do everything that we did tonight, except they're going to do it with what I call the next stage in RC. The Loco-Fi can go in any scale and can take up to what, 24 volts, I think.
24, starting with 7 up to 24.
Right. So that will cover anything any scale that we have. So go ahead, Ken. You can ask your question now, or whatever.
Oh, I just wanted to say with Bob, Loco-Fi works really well. I have been physically using Loco-Fi for more than a year, close to a year and a half. I haven't got a steam engine to put the steam system in yet, but I've had 2 diesels running, ran one today because I charge batteries and just wanted to play with trains. I just love using it. And the plan is to show you how I physically installed it in the 2 locomotives I have, how it hooks up together, and show you a little bit of it running around the track and making noise if you want noise, or if you don't want noise, you don't have to have noise. So it's really good. It's really fun. Works
Ken,
well.
Ken, the problem that I had was I didn't see the part that said hook it up to the Loco-Fi Wi-Fi. I tried to hook up to my local house Wi-Fi.
You
and it
can do
just-
that.
Yeah, you can do it. It won't work, but you can do it.
No, I run mine through my local.
Do you?
Yes. To do it, when you, I'm not going to go into it.
No,
It-
that's okay. I
yeah.
believe it. I believe you.
No, I run mine through there, just because it works really, really well. Either way, the little, if you want to call it Wi-Fi that's on board that you hook it
Yeah.
up to, works just fine.
Yeah.
But it works really well. If you've got your local, you've got it hooked up without it being through the Wi-Fi. When you go back in, you can, I forget what it is off the top of my head. Add loco.
Mm-hmm.
And when you're already have it running, the 2 are paired up, your phone and the Wi-Fi board. Then you put in your password to your Wi-Fi at home,
Uh-huh.
and it will go through
Ah,
the routine where it
okay.
hooks up, and then it will hook right up.
That's
And
good to know.
then, like on your phone, no, I don't want to take a lot of time, but on your phone, when you originally hook up the Wi-Fi and you got your home Wi-Fi, they'll
Mhm.
show up in the connections place as 2 different Wi-Fi units. But after you get it hooked up to your Wi-Fi at home, it won't ever show up again. And the reason I did that was if there was any little problem and it lost something for a second or so, then when it reconnected, it kept wanting to reconnect to my Wi-Fi at home. So I said, well, I'll put it on there so it's networked or whatever you want to call it to my home Wi-Fi. It's real easy. Just add loco. And when you don't have, if you don't enter a password, it just assumes you want to use the Wi-Fi on the Loco-Fi unit in your locomotive. But if you enter a password, that's when it meshes, I think is what they call it, with your home
Okay.
Wi-Fi. And Bob, did Steve give you my phone number if you got any questions?
I haven't given to him yet, okay,
Well,
Ken?
you told me you would.
Well, yeah, I'm a
I'll,
couple
I'll
hours
get it.
off.
I'll get it, Ken. Yeah, but I was pleasantly surprised how well it made everything run.
It does.
Yeah.
It's amazing. It really is amazing. And I'll try to get something together so that everybody else can see how amazing it actually
I'm
is.
looking forward to your conversation.
Ken, please, for my benefit, could you try to keep it simple? I mean, very, my third or fourth grade level works for me on this stuff.
Well, you missed me by a year because I was a fifth grade teacher. So it might be over your head. I don't know what to tell you, Jim.
Bob can explain that my knowledge is very, very minimal.
Hey, it was a battery situation. So you can see it flashing.
There.
Now I'm connected to the locomotive, okay? And I'm running it on the floor now.
Now, let me ask you this. If I want to switch locomotives, then I have to turn the battery off of the locomotive that I'm on, and then turn the battery on the other locomotive. And then what do I have to do to the hand unity? Do I have to press the on
You have
button?
to start all over. You have to flip your button again. Now, you've turned this locomotive off. You're gonna go
Right.
over to the locomotive you want to start. Okay, look. If I turn this on right now, there's no locomotive hooked up. It's gonna flash like that. So I know I don't have this locomotive. So I turn it back off. I go over and I say, I want to start a steam engine. I turn the battery on. I turn this on. This will then go solid here. And I now have control to that locomotive.
Gotcha.
Now, if I have two of these, I can have one controlling this with that procedure I just showed you. And I can have the other one controlling that one over there doing the same repeat procedure. They won't interfere with each other. So I can have one operator can operate this one. The other operator can operate that one. Does that answer your question?
So Steve, does that mean that those units are, the transmitter and receivers are paired together?
Only if I pair them together. In other words, one won't interfere with the other. It's like any of these 2.4 gigahertz systems. They don't interfere with you. It's like your cell phone. Your cell phone has the same 2.4 gigahertz, but my cell phone doesn't interfere with your cell phone. All right.
Let me ask you this, Steve. If I pick up a control, let's say that I've got 5 locomotives, 5 controllers. I pick up controller number 1. I go to locomotive number 2 and start that battery. Then controller number 1 will operate locomotive number 2.
Yes.
If I go and I pick up the next controller and turn it on and turn the battery on, or don't turn another battery on, that controller will not control back the same locomotive the other controller is controlling.
No, that's right.
So I have to have a second locomotive then that I've turned on for that second controller.
Yes. And what we have found is we like to have separate controllers assigned to each engine. Okay. That makes it easy. I know when I pick up number 2 and I have a number. So here's a different manufacturer. You can see I have a 7 on here. That's for locomotive number 7, which is on this little layout back here. Now, I would do the same thing for this I only have 2 of these. And so what I do is I have them at different places on my railroad. So I can leave them there, turn it off here, and then turn it on over there and get it to work leave the controller here. It doesn't make any difference. Just remember, this controller controlled 1 engine. Whatever you assign to this controller is the engine you will control. If you turn it off so you don't control it anymore, you can then go to another engine and control that one. But the first engine has to be turned off. Okay? But if I have this engine turned on over here, and I have another controller over here, I now have 2 trains that can run. Is that clear?
Yep.
It's well, you don't have DCC, you have DC. So I don't know how you run more than 1 trolley on without having a rheostat type situation. I don't even know if you can do that with overhead.
I use
But
diodes. I use diodes.
Okay, then anyway, you can run 1 of these with 1 locomotive.
Yep.
It could be any locomotive as long as you are bound or bind with a locomotive. Once you're bound with that locomotive, you can't bind at the same time with 2 locomotives.
Got it.
Okay?
Got it. Yep.
So
Hey, Jim, it's sort of
Anyway.
like a guy walking into a room with 10 women. You can go over and talk to one woman, and then you can disconnect that conversation and go over and talk to another woman, but you're only talking to one woman at a time.
Gotcha.
yeah,
Gotcha. Gotcha.
you know. Thanks, Bob.
That's okay.
I only talk to one.
You got to keep it simple for me, Steve.
Some of the things that I've learned to do to help me know when batteries need charging or locomotives I have used for a while is I take these little clips and I set them on the rail in front of this one says charge. So I know that this locomotive that I have in front of, that this is in front of, it says charge. I know that I need to charge that locomotive, the battery in that locomotive, okay? So that's just some of the things I do. I have made up several of these and set them around the railroad. And then and sometimes I keep a log in a little index card of the batteries that I've used, X number of days. I know that, it's going to be low, so I'm going to have somebody over. I know that I need to take that locomotive battery and charge that up full, so it'll be ready when people come over to run. And those are things you just know how to do. You just develop your own type system.
Anybody have any more questions for Bob or for Steve or Ken? Well, thank you so much for the explanations tonight, guys. I mean, I think I'm starting to understand this slow but sure.
Well, I had a little more. I don't know if I have any more time. I don't know what you have left, but anyway, I've got one more segment where I'm going to show taking the stuff out of the car. I'm going to take the car, take it apart, and show how we get all the parts we're going to put in the engine.
Why don't you do that next week?
I will. That's what I'm going to do, and then we'll have Locofy on the 8th, and then after that we're going to go back to, what do you want to talk about?
Sounds
I
good
won't
to
have
me.
anything left to say.
Well, if there are no more questions for anybody, then we'll move on here.